All right, let's dive in. We're going under the hood of the AI that's everywhere these days. ChatGPT, Claude, you name it. I'm talking about large language models. Now, you've probably played around with them, right? But have you ever wondered how they actually work? How do they go from a few words you type in to, well, a whole complex answer? That's what we're here to figure out. The whole mind-blowing technology really comes down to this one question. It can feel like absolute magic, but behind the curtain is this incredible process built on prediction, data, and just immense scale. So today, we're going to pull back that curtain and show you exactly how the trick is done. So to really get this, we have to start with a fundamental blueprint. What even is a language model? Okay, so at its absolute core, an LLM is just a giant prediction engine. The best way to think about it is like the autocomplete on your phone, But just on a cosmic scale. Seriously, after being trained on a huge chunk of the internet, its one single job is to guess the most probable next token, which can be a word or even just part of a word. That's it. Everything else, all the incredible things it can do, flows from this one simple but massively scaled task. What's so wild is how different this is from older AI. Traditional models were specialists, right? You'd build one just for translation, another for figuring out if a review is positive or negative, and you had to spoon feed them thousands of carefully labeled examples. LLMs, they're generalists. They learn all by themselves from the raw text of the internet, and that one single model can turn around and do dozens of different things. So we've got the blueprint, this next word predictor. But the real magic, the secret sauce, happens when you add the engine, scale. And as you're about to see, making these models bigger doesn't just make them a little better, it makes them fundamentally different. Researchers figured out this thing called the chinchilla scaling law, which is basically the recipe for success. It turns out you can't just make the model's brain bigger without also feeding it more information to learn from. The sweet spot, the optimal strategy, is to scale both of them up together, in balance. That's what really unlocks the potential. And this leads to a super interesting question. We're following the recipe, we're making the model and the data bigger and bigger. So what actually happens? Well, the answer turned out to be one of the most surprising and exciting discoveries in the entire history of AI. They develop what are called emergent abilities. These are skills that nobody programmed into them. They just appear once the model gets big enough. This was the moment AI started to genuinely surprise its own creators. Smaller models just can't do this stuff, but suddenly the big ones can reason through logic puzzles or learn a brand new task just from a couple of examples you give it in one prompt. Okay, so here's a crucial point. We've built this incredibly powerful engine, but a raw engine by itself isn't very useful, is it? You need a steering wheel, you need brakes, you need safety features. This is where the whole process of alignment comes in. It's how we tame the AI. Now, the classic way to do this is called reinforcement learning from human feedback, or RLHF. Think of it like a three-step dance. First, you have humans compare two different AI answers and just pick the one they think is better. You do this thousands and thousands of times. Second, you train another, smaller AI, a reward model, to get really good at predicting which answers the humans are going to like. And finally, you use that reward model to fine-tune the main LLM, basically teaching it to give answers that get a high score. And this is just so critical. Without this step, you just have a powerful text predictor that might ramble or be unhelpful or even toxic. This alignment process is what shapes that raw power into the helpful, harmless assistant that you can actually have a real conversation with. But RLHF is pretty complex and expensive. So lately, a newer technique called direct preference optimization, or DPO, has gotten really popular. It's super clever. It skips the whole separate reward model step and finds a mathematical way to directly train the LLM on those human preference pairs. The upshot? It gets the same, sometimes even better results, with a much simpler one-stage process. Okay, so the AI is built, it's been scaled up, and it's been aligned. Now let's flip the script and look at it from our side. How do we, the users, actually talk to this thing to unlock its full potential? So let's take a look at a simple math problem. You ask the AI, and it just blurts out the answer is 11. Now, it's correct, but we have no idea how it got there. It's a total black box. And this is a classic problem. The AI just jumps to a conclusion, which makes it really hard to trust its reasoning on anything more complicated. But check this out. Watch what happens when we add one simple little phrase. Let's think step by step. All of a sudden, the model lays out its entire logic for us. It shows its work. 2 cans of 3 is 6. 5 plus 6 is 11. This technique is called chain of thought prompting, and it massively improves how well the AI performs by forcing it to slow down and actually reason instead of just guessing the answer. We can also control the AI's personality, so to speak, using a setting called temperature. If you set the temperature low, it's very focused and always picks the most obvious next word, which is perfect if you're, say, summarizing a legal document. But as you turn the temperature up, like we see here, it starts giving more weight to creative and even unexpected words. This makes its writing way more random and diverse, which is awesome if you're trying to brainstorm ideas for a story. And finally, let's talk about the weird parts. These models are incredibly powerful, but they also have some really strange limitations that you absolutely have to understand if you want to use them well. The most famous quirk is something called hallucination. This is when the model just makes stuff up. It might invent a historical event or cite a scientific paper that just doesn't exist. And it happens because, remember, it's a word predictor, not a fact database. It's just trying to generate text that looks right, which is exactly why you can't just trust it to do your homework without double-checking everything. And check out this chart because it shows another really bizarre limitation, the lost in the middle problem. When you feed an AI a really long document, it pays a ton of attention to the stuff at the very beginning and the very end. But the information buried deep in the middle, it's much more likely to just ignore it completely. It's a great tip. If you have a critical piece of information for the AI, always put it at the start or the end of your prompt. So all of this brings us to one final big question. We've managed to build machines that are masters of the statistical patterns in our language. They can write, they can code, they can reason in ways that feel almost human. But the huge challenge for the future is bridging that gap, the gap between mastering language and truly understanding the world that language describes. And honestly, that's a question we're all going to be exploring for years to come.